Hello everyone, welcome to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungri, MSc MPhil Mathematics from C.D. King Higher Secondary School, Jotsama, Kohima. In the last session, we learned what is a relation and what are its types, reflexive, symmetric and transitive. If R is we define a relation R in a set A, it's called reflexive when A comma A belongs to R for every A belongs to A. This is for every A. Whatever we take the elements in set A, every element should satisfy this condition. Then only we call it as reflexive. Then when we call the relation as symmetric, for any A comma B belongs to A, for any, we have to be careful here. If A comma B belongs to R, then B comma A must be belonging to R. If we have this ordered pair in the relation, then we should have the reverse pair also. If we don't have this pair in the relation, we don't need to worry about it. As long as we have this pair, we should have the reverse pair. Then only we call that relation as symmetric. The last one is transitive. For any A, B, C belongs to A, if AB belongs to R and BC belongs to R, then we must have A comma C belongs to R. That is the extreme components. We should have the ordered pair also in the relation. If we don't have this two pairs in the relation, we don't need to worry about this. A comma C belongs to R. If a relation is reflexive, symmetric and transitive, we can easily call that relation R as an equivalence relation. Okay. In this session, we will learn some problems on this relation, how to solve it. Okay. First, the question is, show that the relation R defined in the set A has the elements 1, 2, 3, 4 till 14 as R as defined as is the set of all x, y such that 3x minus y is equal to 0. So, let us find out what are the pairs will be in this relation R. So, solution, what is given? A as 1, 2, 3, 4 etc. till 13, 14. And see these questions, this type of questions usually comes in 4 mark. So, we have to be very careful with the steps. The steps are very important, no jumping steps. Then R is defined as xy such that 3x minus y is 0. Okay. So, I am going to find the ordered pairs here. Here this one, can we write it as y equal to 3x? Easy to find out for us the ordered pairs. If I give x equal to 1, let us start from 1. If you give 1, y you will get 3. Therefore, 1, 3 is in the relation. If we give x, then we get y as 3. So, 1 comma 3 is in this relation. And similarly, if you give 2, what do you get? 6. So, 2 comma 6. And 3, 9 will be there. And then 4, 12, right? And then if we give 5, if you give 5, then y will take 15, isn't it? But 15 we don't have here. So, let us avoid that ordered pair. So, only these 4 ordered pairs we have in the relation. Now, we have to check whether so that the relation R defined in the set as equivalence, reflexive or symmetric and transitive. We can change this question as check whether the relation. Check whether the relation R defined in the set A as this one, is it reflexive, symmetric or transitive? We have to check it out. Alright. First we will see whether it is reflexive or not. For the reflexive, okay. What is the condition to be reflexive? AA should be belonging to R for every A belongs to A. Whatever the elements in A, all the elements should have the pair like this. That means every element should be related with itself. Okay. Do we have those type of ordered pairs? No. 1, 1, 2, 2, 3, 3, 4, 4. No, we don't have, right? For any element, we don't have this. Therefore, clearly, x does not belong to R for every x belongs to A, right? Therefore, R is not reflexive. not reflexive. Even if it fails for one case also, we can say that it is not reflexive, but we don't have any single pair here. Suppose 1 to 13, we have all the pairs 1, 1, 2, 2, 3, till 13, 13 we have, but 14, 14 we don't have. Still it is not reflexive. Okay. Then the second one is symmetric. Symmetric. So what is the definition for symmetric relation? For any AB belongs to A, if AB belongs to R, then BA must be belonging to that R, right? Okay, let us check. 1, 3 we have, but the reverse pair 3, 1 we don't have in the relation, isn't it? So not only for this, all these ordered pairs also we don't have like reverse pairs. Therefore, it is not symmetric. Here it is clear that 1, 3 belongs to R, but 3, 1 does not belongs to R, right? Just I am showing one example. One example will do to prove it is not symmetric. R is not symmetric. Okay. Then the last one is transitive. Let us check for transitivity. So what is the definition of transitivity? For any ABC belongs to A, if AB belongs to R and BC belongs to R, then we should have AC belongs to R. Okay, let us check for an example here. 1, 3. So this is the second component. Starting with 3, we have this ordered pair 3, 9. Okay, so this is AB, this is BC. Do we have 1, 9 in this relation? No. See, 1, 3 belongs to R, 3, 9 belongs to R, but we don't have 1, 9. Therefore, it is not transitive. I already told you, even it fails for one case also, it is enough, it is good enough to say that it is not transitive. Okay. So here from the relation 1, 3 belongs to R, 3, 9 belongs to R, but 1, 9 does not belongs to R. Therefore, R is not transitive. So, yeah. Okay. So, this relation, whatever it is given in the question, it is not reflexive, not symmetric and not transitive. To prove it is not reflexive, not symmetric and not transitive, we have to show only one example. To prove it is reflexive, it is symmetric, it is transitive, we have to check for every pair present in the relation. Okay. Yeah, let's move on to the next one. Okay, the second problem is show that the relation R in R. So this represents the relation, okay, and this R is the set of all real numbers. Don't get confused. This represents the set of all real numbers. Okay, defined as R is the set of all AB such that A is less than or equal to B, is reflexive and transitive and but not symmetric. We have to prove it is reflexive and transitive but not symmetric. Okay, given R as AB such that A less than or equal to B. This is the relation given to us. We are considering the domain and codomain, the real numbers, set of all real numbers. Okay. First one is we have to check for reflexivity. Okay. So all the numbers are equal to itself, isn't it? All the real numbers are equal to itself. Here less than or equal to, it should be either less than or equal to. That is the meaning of writing less than or equal to. If it is strictly less than, it is not reflexive, but it is given less than or equal to. So we consider the second one, that is equal condition. Okay. So we know that x is equal to x for every x belongs to R, right? For any real number, if we take, then all the numbers will be equal to itself. So which implies x comma x belongs to R. This is relation for every x belongs to R. Okay. Therefore, R is reflexive. The steps are very important. Straight away writing it is reflexive, it is symmetric, it is transitive, you won't get the full mark. Okay, maybe it is useful for your competitive exams. You can just guess whether it is reflexive, symmetric or transitive by having a look. But in the board exam, you must write the steps clearly. Reflexive. Then let us check for transitivity. Transitive. So what is the condition for transitive? For any ABC belongs to A, if AB belongs to R and BC belongs to R, then we must have AC belongs to R. Okay. So let us take 3 real numbers. For any 3 real numbers X, Y, Z. Okay. It is clear that X is less than or equal to Y and Y is less than or equal to Z. In such a way, if we take like this, X is less than or equal to Y and Y is less than or equal to Z, then automatically X is less than or equal to Z, right? So you see the real number line. If you take -2, 0 and 1, this is X, this is Y and this is Z. So X is less than Y, that is -2 is less than 0 and Y is less than 0, that is 0 less than 1. It is clear -2 is less than 1, isn't it? So we can say that X is less than Z. That's why we are taking like this. For any 3 real numbers, if you take like this, if it is X less than Y and Y less than Z, then we have X is less than or equal to Z. Therefore, X comma Z belongs to R relation. Therefore, R is transitive. Okay. Then this last one, we have to prove that it is not symmetric. It is already given, it is not symmetric. So we have to show just an example. Not symmetric. Let us take 2 real numbers. Okay, let us take 2 real numbers, 2 and 4. You can take any 2 real numbers. I am choosing 2 and 4. See clearly 2 is less than 4, right? Okay, if 2 comma 4 belongs to R, which implies 2 is less than 4, right? But 4 is not less than 2, right? Which implies 4 comma 2 does not belongs to R. Hope you understand. Symmetric means we should have the reverse pair. If we consider that 2 comma 4 belongs to R, then we have 2 is less than 4, right? But 4 is not less than 2. Therefore, we cannot have this 4 comma 2 belongs to R. Therefore, R is not symmetric. Okay. So this is reflexive, this is transitive, and it is not symmetric. Okay. Show that each of the relation R in the set A is a set of all x belongs to z, z for integers, 0 less than or equal to x less than or equal to 12, given by R as defined as set of all a, b such that absolute value of a minus b is a multiple of 4, is an equivalence relation. Find the set of all elements related to 1. Okay. So here we have to show that it is an equivalence relation. That means it is reflexive, symmetric and transitive. Okay. So solution. So let me write the order pairs in the relation. AB that is absolute value of a minus b is a multiple of 4, we have to consider from 0 to 12. If you want to like write all the pairs and you want to check the reflexivity, symmetric and transitive, it's fine. We can do in general also. So first one is we have to check for reflexive. Okay. So let us take an element A from this set A, capital A, right. So absolute value of A minus A is 0, right. A minus A is 0, and if you take the modulus value, you will get 0 again. It is a multiple of 4, right. Therefore A belongs to R for every A belongs to A, right. You take any number from 0 to 12 and you subtract itself, then you will get 0. 0 is a multiple of 4, therefore it is reflexive. Therefore R is reflexive. Okay. The second one is symmetric. Let us take two numbers AB from A. Okay. If AB belongs to R, suppose AB belongs to R, then we have A minus B is a multiple of 4, right, as per our relation defined in the question. This is a multiple of 4, okay, which implies if I take minus outside here, we will get B minus A, right. This is also multiple of 4, right, and we have B minus A is a multiple of 4, right, okay, which implies BA belongs to R. Therefore R is symmetric. Okay. Then for transitive, for transitivity, let us take three elements for A, B, C belongs to A. If AB belongs to R and BC belongs to R, then what do we have? A, absolute value of A minus B is a multiple of 4, and absolute value of B minus C is a multiple of 4, right, which implies absolute value of A minus B is equal to 4 times K1. So it's a multiple of 4 means some number, product of a number with 4, right. So that's why we are writing multiples of 4, and this one can be written as B minus C is 4 times K2 for some K1 and K2. Then let me add these two. So what do we get? Absolute value of A minus B plus absolute value of B minus C is equal to 4K1 plus 4K2. So we can put together this one, absolute value of A minus B plus B minus C is 4. If I take K1 plus K2 we get. Then this is absolute value of A minus C, that is equal to 4K3. I'll just put this two number addition as some number K3, then which implies A minus C is a multiple of 4, right, which implies AC belongs to R. Therefore R is transitive. Okay, so we have to conclude it carefully as R is reflexive, symmetric and transitive. R is an equivalence relation. The conclusion is very important. Okay. And the last one, there is one more question here. Find the set of all elements related to 1. Okay. So one of this number is 1. Absolute value of A minus B is a multiple of 4, right? So one of the number is 1. We have to find out the other number so that the absolute value will be a multiple of 4. So 1 minus 1 is 0, right? It's a multiple of 4. And 1 minus 5, you get 4, right? So 4 is a multiple of 4. And then 1 minus 9 is 8. So it is also a multiple of 4. So the set of all elements related to 1 are 1, 5, 9. Okay, that's all. Thank you.